Okay, so on to question 6, which just asks, how would you balance this equation? So we have CH4 plus O2, leave a space. Okay, so when balancing questions that contain kind of like the same atom and multiple compounds, so for example, there's an oxygen on our reactants, and then there's also an oxygen in carbon dioxide and also in water. So I know I want to balance my oxygen atoms last because I don't have to like double take and go back and try to balance oxygen after the fact. So first, I would usually just balance the carbons and then the hydrogens and then the oxygens. But in the case of carbon, there is only one carbon on our reactant side and one carbon on our product side, so it's already balanced. So the first step is just to balance my hydrogens. So on our reactant side, there are 4 hydrogens, and on our product side, there are 2. So I'm just going to put a coefficient of 2 in front of HCO just to show that we need 4 hydrogens on the product side as well. Okay, so now that all the hydrogens are balanced, now I want to balance my oxygens. So on our product side, you'll see we have 2 plus 2, so there are 4 oxygens in our product side, so I'm going to write coefficient of 2 in front of the O2 in our reactant side, and now everything should be balanced. So we can double check, there is 1 carbon, there's 4 hydrogens, and then also 4 oxygens. Okay, so let's see what the junior tutor said. To balance this equation, we perform balancing by inspection, which is basically trial and error. There are some techniques to guide us in balancing the equation, but first we balance the element that is not an oxygen or hydrogen by multiplying it with a coefficient so that the number of molecules of the atoms in the reactant side of the equation is equal to that on the product side. We do not need to balance carbon since both the number of carbons are equal to each other. So we balanced hydrogen next, and to balance hydrogen, we multiply H2O by 2. Lastly, we balance oxygen by multiplying O2 by 2. We check the equation if it is balanced by accounting for the number of moles of elements in each, and this is shown in table 1. Yep. So the solution is correct.